Alrighty, let's do some graphing here. And you may notice this looks like a screenshot from a Word document. In fact, I just screenshotted a quiz, so you have the same layout as the quiz, and I just have a different equation there. So it's going to ask you the same exact stuff on a quiz or a test. Look just like this. Alright, so it'll be nice and familiar when you get there to that assessment that you guys are all so excited about. Okay, so first thing I want to do when I'm trying to graph something is I'm going to take a look at my equation. I'm going to factor that equation. I'm going to factor the numerator and the denominator. Okay, so the first one looks like a GCFer. I'm going to take out a 2x, and I'm left with x minus 4. In the denom, I'm going to take, let's see here, AM method. What multiplies to 4 and adds to negative 5? Will that be x minus 4, x minus 1? Woo woo! All right, we're factored. That's the first thing. Domain. What is x not allowed to equal? I don't want my denominator to be 0, so x cannot equal 4 or 1. So x cannot equal 4, x cannot equal 1. Awesome. Next thing, wholes. Well, what cancels? X minus 4's cancel. So I have a whole at 4, comma, 4 comma what? How would I figure that out? Well, why don't I write out my simplified version of this function here where I've made some simplifications. I have 2x over x minus 1. How can I get my y coordinate? Ooh, if I plug back in my x, I can get my y. So for that one, I would have 2 times 4 is 8. 4 minus 1 is 3, so 8/3. So there's my whole. Okay, x-intercept. X-intercept. Well, we've done these before, especially when we were doing some parabolas. We figure out where it crosses the x-axis. We also did it when we were dealing with functions like with a degree of 3, like a cubic function or quartic functions. So basically, if the equation, if I set it equal to 0, right, because if I set it equal to 0, that means that I am along the x-axis. If my y value is 0, I'm hitting the x-axis somewhere. So if I take this and I say 0 equals 2x over x minus 1, I really just need to worry about the numerator being 0 because 0 divided by anything is 0. In this case, if I plug 0 in for x, so I can just kind of ignore this guy down here, 0 equals 2x. If I divide by 2, I'm going to get x is 0. So my x-intercept is at 0, 0 for this one. Cool. How about my vertical asymptote? Well, vertical asymptote is just what's left in the denominator after simplifying, so that guy right there, right? Alrighty. So it's going to be x equals positive 1. And my horizontal asymptote, I like to look at my original, the OG, the original function. So I have degrees that are the same, x squared and x squared, which means it's the lead coefficient over the lead coefficient, so 2 over 1. So y equals 2 over 1 or just 2. All right, so I've got basically my building blocks for this function, to graph this function here. So I'm going to start plotting some vertical asymptotes, horizontal asymptotes, and then we'll get to the ordered pairs. Sound good? My vertical asymptote is at x equals 1. I'm actually going to zoom in here a little bit onto the graph. So I've got my x equals 1. And my y equals 2 for my horizontal asymptote. All right. And then I believe my whole was at 4 8/3. And my x-intercept at 0, 0. So I can do an x-intercept at 0, 0. And then it was 4, then comma 8/3. Well, 8/3 is basically like 2.67, so 2 2/3. So if I go 4, comma, then 2 2/3, and keep in mind it is going to be an open circle there. All right, that looks nice. That's our hole in the graph. So now let's get some other ordered pairs here. All right, we can actually use our calculator and our table on our calculator to do so. So let's plug the function into our calculator now. Alright, so once we plug this into our calculator, we're going to put down some ordered pairs here. Make sure that you put in parentheses around the numerator and denominator if you don't have the fancy fraction button on your calculator. Alright, if you're just doing it with the division sign, make sure you got the parentheses around that. If you can do the alpha y equals and choose the n over d and get a nice fraction, that's always good. And then you're going to hit second and graph, which is going to give you a table. And what I like to do is I like to find my vertical asymptote, which is at x equals 1, and I put that in the center, and I get like 3 values around each, okay? So my vertical asymptote, we'll say, is right in here, okay? And I'm going to go around that. So I'm going to have -2, -1, and 0 for my x values. Then I got my 1 for my vertical asymptote, and I've got 2, 3, and then 4. Okay. So for -2, I've got 1.3. Then -1, I've got 1. 0, I've got 0. Cool. And then 2, I've got 4. And 3, I've got 3. Looking awesome. 4, I already know that one from over here, right, is 8/3, or 2.67 essentially, if you like decimals a little bit better. So let's go over here and plot these. Alright, so -2, 1.3, -1, 1, 0, 0 we already have. So my graph is going to look something like that. Notice how it gets really close to the asymptote but never quite touches. Same thing over here. 2, 4. Okay. 3, 3. And then 4. Well, that's a terrible looking point. There we go. It's a little better. And then we have 4 and 2.67 for our hole. And once again, I'm going to go right along there. Kind of stops when you get to the hole. Starts up again. Sorry, I kind of missed those points. It's a little tough on the iPad, but you get the idea. It goes up and along, very close, always getting closer to that asymptote, but never touching or crossing that asymptote. Okay? That's very, very important. So easy places to lose points on a quiz. Accidentally crossing the vertical or horizontal asymptotes, right? Forgetting to make sure that you, put a hole on the graph where there should be a hole on the graph. Another one, over here, you might forget to put x equals. You might forget to put y equals. Make sure you have x equals or y equals. Make sure you've got ordered pairs here. Make sure you say that x does not equal these two numbers. Those are all little areas for you to lose points. We don't want that. All right. Nice work. Sorry it's a long video, but it is a lot of work to graph one of these. But so much fun. So fulfilling. Right? It's almost like community service in a way. It's fulfilling activity, graphing rational functions.